Okay, we are solving the question that we have on our screen. The marks of 40 students in a class were recorded as follows. So we have that table. We are told most of the students scored 22 marks. Most of the students scored 22 marks. So we need to work out the value of x and y, and then we work out the median, the standard deviation, and do those explanations that are required there. So we start by interpreting this word most. We know most stands for mode. So most stands for mode. So we recall the formula for mode of grouped data. Mode of grouped data. So we have this formula that we know very well. The formula for mode is MO is the lower class boundary of the model class plus D1 over D1 plus D2, and we multiply that by I. And we remember that LCB is the lower class boundary of the model class. D1 is the difference between the model class frequency and the frequency for the lower class. And then D2 is the difference between the model class frequency and the frequency of the higher class. And I is the size of the class interval. So we need to remember that. So we can go back to our table. We are told that most of the students scored 22 marks, meaning that the model class is the class 20 to 30. The class 20 to 30 is the model class. Looking at this data, you can see the classes range from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. So the data is already continuous. So now that the data is already continuous, it implies that the lower class boundary of the model class is 20. The model class the lower class boundary of the model class is 20, since the data is already continuous. And then D1, so let us first of all write that the lower class boundary the model class is 20. D1 is, we look at the table, we have 15 minus x as D1, and D2 as 15 minus y. So D1 is 15 minus x. D2 is 15 minus y. Let's look at that clearly. Yes, the model class frequency is 15. The frequency of the lower class is x. The frequency of the higher class is y. So we are okay as far as D1 and D2 are concerned. What about I? the size of the class interval, we simply take 30 minus 20. So I is 30 minus 20 because again the data is already continuous. So we come and say mode, which we already know as 22. We know the mode is 22, is given by 20 plus 15 minus x over 15 minus x minus 15 minus y. So not minus but plus 15 minus y. So, and we are multiplying this by I, which is 10. Multiplying that by I, which is 10. So we can see that when we bring 20 to this side, we have 2 is equal to 15 minus x over 15 plus 15 is 30 minus x minus y. All this multiplied by 10. So that if we divide both signs by 10, we are going to have 0.2 is 15 minus x over 30 minus x minus y. We do cross multiplication. We are going to get 15 minus x is equal to 0.2 times 30 minus x minus y. So we have 0.2 times 30. We work out that 0.2 times 30. We get 6. So we have 15 minus x is 6 minus 0.2 x minus 0.2 y. So we have 0.2 y minus 0.8 x is equal to -9. Okay, so we can rewrite this as 0.8 x minus 0.2 y is equal to 9. So we are looking for the values of x and y, and you remember that this is a class of 40 students, implying that if we add 4 plus x plus 15 plus y plus 6, we should get 40. And now that we have 4 plus 6 is 10, 25, it implies that x plus y is 15. So we have two equations to solve simultaneously. We have another equation here, x plus y is equal to 15. So solving this simultaneously, can multiply by 10 and get 8x minus 2y is equal to 90. And if we multiply the second equation by 8, we'll have minus plus 8y is equal to 120. And we can do the subtraction upwards. So that we get 10y is 30, y is 3. If y is 3, it follows automatically that x is 12 because x plus y is 15. So we are done in as far as getting the value of x and y. As far as getting the value of x and y, we are already done. So what is important in that part of the equation is to be able to interpret the word most stands for the mode. Once we know that, then it's possible to get the values of x and y as we have done. We could move on and now get the median mark, the standard deviation, and then we do the other explanations. So allow me to clear the board here so that we have space to work out the median. So for us to work out the median, we need to write our table. Our table is, we have the class there, we have frequency, and we need the cumulative frequency. So we have 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. The frequencies are 4. We have already found that x is 12 and y is 3. X is 12, y is 3. X is 12, we have 15, we have 3, and we have 6. So the cumulative frequencies are 4, 16, 31, 34, and 40. So to get the median, we need first of all to identify the median class by taking, so to get the median class, we need to take 40, divide by 2, get 20, and we look for 20 along these cumulative frequencies. So 20 is around where we have 31. And so what we just need to do is to recall our formula for median, that median is given by the lower class boundary of the median class plus n over 2 minus c over f times I. And we replace those as we write them. So the median is going to be, the lower class boundary of the median class is 20 plus 20 minus the cumulative frequency above the median class is 16. The frequency of the median class is 15. And I is 10. So we work out that. When we work out that, we get 20 plus 40 divided by 15. 20 plus 40 divided by 15. So we add that to 20, and we get 22.66 as the median. That is the estimate for the median. It is the estimate for the median. Now we would want to work out the standard deviation. For the data, we have been told to use an assumed mean. So So we go ahead and write the table. Make our table. We have the class. Let's see here. We have the class. We have the frequency. We have the midpoint of each class. And we have the deviations from the assumed mean. So if we go back to our table is 0 to 10, 10 to 20, 0 to 10, 10 to 20, 20 to 30, 30 to 40. I suppose we also have 40 to 50. Let's confirm that. We have 40 to 50, so we have 4, 12, 15. 4, 12, 15. 4, 12, 15 is the frequencies. And then we have 3 and 6. We have 3 and 6. 3 and 6. We have been told to use the 25 as an assumed mean. We are using 25 as an assumed mean. So what we are going to do, first of all, we write the midpoint of each class. The midpoint of the first class is 5. 0 plus 10 divided by 2. The midpoint of the other one is 15. 25, 35, 45. So we get the deviation of every score, of every x from 25. So this gives us negative 20, negative 10, 0, 10, 20. We can actually even use a coding method because we can see that we can decide to get u, which is every deviation divided by a constant. We can see all these are divisible by 10. So we can have u there. Each of these scores we divide by a constant, which is 10. Get negative 2, negative 1, 0, 1, 2. We get f times u as negative 10, negative 15, 0. We are taking f times u. F times u is negative 8, negative 12, 0, 3, and 12. That is f times u. F times u. F times u. Then we have a column for f times u squared. So this times this becomes 16, 12, 0, 3, and 24. So we sum f times u, sum of f times u squared. So we have negative 20 plus 15, giving us negative 5 there. And then we have 28 plus 27, giving us 55. So we need to get the variance, and then we get the standard deviation. So we need to, again, to recall the formula for variance. The formula for variance using a coding method is s squared, c squared, sum of f u squared over sum of f, minus sum of f u over sum of f, all that is squared. So our constant is 10, so we have 100 there. Then we have 55 divided by 40 minus negative 5 divided by 40. All that is squared there. So we work out and get we have 100. We have 55 divided by 40. 55 divided by 40 is 1.375 minus, we have 5 divided by 40. 5 divided by 40 is that, and then we square it, we get 0.015625. So we are going to get 100. We multiply by 1.375. We subtract 0.015625. 625, and we get 1.37375. So this is approximately 135.737. So that is the variance. And so S squared is 135.737, and the standard deviation is the square root of that. The standard deviation is the square root of that. So what is the square root of that? We need the square root of 135.735. 735 is approximately 11.65. So the standard deviation for the data is 11.65. That is the standard deviation. So we have used the coding method. Allow us to conclude by answering these questions. Explain why the standard deviation is better than variance when used as measures of dispersion. The standard deviation is better than variance because variance is given in square units, which are hard to understand and interpret. So the standard deviation is easier to understand and interpret because it's given in terms of the units of the data. So we have answered that one. Under what condition would you prefer to use the mode rather than the mean as measures of central tendency? We use the mode when we have categorical data. We have data female, female, male, male, female, or yes, yes, no, no, no. This is called categorical data. So in such a case, the mean might not, the average might not have a meaning, but the mode, we would prefer to use the mode as the measure of central tendency in that case. So I want to believe that is clear. We have solved that problem, and next time we'll solve another one of a different kind. Thank you.